This is example 2.5. This time, we want to know how much you should deposit every year uniformly. So this is A, this is A, and you're going to continue this one for n number of periods. You want to know how much you should deposit here to have F amount of dollar at the end of n period. Again, we are assuming even you're withdrawing at the end of your n, still there's a payment there. So this is payment A. So these are all my payments. The equation for this A is going to be called F times I over 1 plus I to the n minus 1. So this is the actual equation. So if you notice in this example, A is unknown, F is given, N is given, and I also given. You're trying to find A value. So this is the actual equation. If you are using table, it's going to be F, because A is given, we call this on F given A, with I interest and n number of period. So let's go back to refer to example 2.5. In this example, you want to know how much you should deposit every year for next 10 years to have $10,000 10 years from now, if the interest rate is 10% per year. So basically, my A value is unknown, my F value is 10,000, and the interest rate is 10% per year. And finally, the number of period n is 10. So I'm going to use the equation first, then we're going to use table. The A is going to be equal the future value, which is 10,000. That's given. Times I, which is 10%. 1 plus 10% to power of 10 minus 1. If you do this calculation, the A value is going to be $1,095.46. So this, if you are using the actual equation, the easier way to do it, just using the table. So now I'm going to show you how to use table. The A is going to be called F. Now remember, the F given, you're trying to find A. That's why we call this on A given F with I and N period. Now we're going to substitute for the number. F is 10,000. A given F. The interest rate is 10%. The number of period is 10. Now you have to go back to your book. At the end of your book, page 608. So you go under column A given F column with 10 number of period. You're going to get this number from the table. You should get 0.10955. If you solve for this, you're going to get $1,095. As you can see here, there's a difference of 46 cents. Again, that's just because of the round-off error. Always you're going to have this difference. Sometimes you're going to be exactly the same, but most of the time you're going to be off by $1. So that's acceptable. Now, as you can see, this method is much faster because you just do it one multiplication. Here you have to do just some power. It's going to take longer time. Especially in the exam time, it's going to save you a lot of time. Try to use table as much as possible.